class. In this video, we'll be finding E given a set of statistics. So given that sigma is 3.6, x bar is 10.2, n is 65, and a 90% confidence level, use the confidence level and sample data to find the margin of error, E, and round your answer to the nearest thousandth. Assume this information comes from data that is normally distributed. Hint, find the confidence level first and then find E. So the first thing I'm going to do is bring up my formula chart. Because since I'm estimating a parameter that is a mean, I know that I have to choose between the normal distribution or the student t distribution. And my cheat sheet here, or my formula sheet, is going to help me with that. So I look under the parameter column and I find the two entries for the mean, or mu. The first row is going to be for the normal distribution, and the second row for mu is going to be for the student t distribution. So then I'm going to look at the requirements column, and this is going to help me determine which I will use. So for the normal distribution, I see that I need sigma to be known and the population to be normally distributed, or sigma known and my sample size greater than 30. For the student t, I need sigma to be unknown and a population normally distributed, or sigma unknown and n greater than 30. So which one am I going to use? For this problem, the first bit of information I was given was sigma, so I know that I need the normal distribution, because the problem does confirm that it is a normal distribution, and my sample size n was 56, which is much greater than 30. So I'm going to use the normal distribution. So I pick that row that has the normal distribution, and I look further to the right to find how to get my confidence interval. And as with all of the confidence intervals, you're going to have two options here. You can either use the by-hand formula, which is your point estimate plus or minus the margin of error, but I'm not given a margin of error here, so I'm going to use the second option, which is the calculator. And for my case, I'm going to use the z interval function. All right, so I'm good to go there. So I want to use z interval. All right, and again, that is because sigma is known. Okay. Typically, the other two requirements won't come up too much. It's mostly whether or not you have a sigma or an S. Okay. All right, so now let's pick out the information that I have, because I'm going to need to put that information into the calculator when I access z interval. So the first is sigma, which is 3.6. Then I have a sample mean, or x bar, of 10.2. And then it tells me my sample size n is 65. And then it says I have a 90% confidence level. So my confidence level is going to be 0.9, because I always convert that to a decimal. All right, so now let's go and find z interval and plug in this information. All right, so I'm going to bring up my calculator here. So to find the z interval function, I'm going to hit stat, tab over to tests, and then z interval is option 7. I'm going to go ahead and tab down and hit enter. So the first item on my list here, once I've clicked on z interval, is input, and I have to choose between data and statistics. In this case, I'm just given a list of stats. I'm not given a big set of a table of data or anything, so I'm going to keep it on stats. So now I need to fill out sigma, my population standard deviation, which we said was 3.6. All right, and then my sample mean is 10.2. My n is 65, and my confidence level is 0.9. All right, once I have all that filled out, I hit calculate. Okay, and then I'm given my answers. So remember, I've mentioned this a few times here. This is the same as with all the other interval functions. Only hit enter once. If you hit enter twice, you'll get an error or just be taken to the home screen and it'll look like nothing happened. Okay? So now that I have my answer, the answer I need is going to be the two numbers inside the parentheses. It's usually the first thing listed. Okay? In this case, my answer is the lower confidence limit of 9.4655 and an upper confidence limit of 10.934. Now this problem tells me to round to the nearest thousandth, which is the third decimal place. So for my lower confidence limit, I have 4 decimal places, so I'm going to round that to 9.466. And then my upper confidence limit only has 3 decimal places, so I'm going to leave that. Okay, so let's go and record my answer. So my confidence interval is 9.466, comma 10.934, and I keep that in parentheses. And then it says to find E, you're going to need the upper limit minus the lower limit divided by 2. All right, this formula is in your formula sheet too, but we left it here in blue for you at the bottom of the screen just as a hint. Okay, so my upper confidence limit is 10.934. Your lower confidence limit is 9.466, and then divide by 2. So the way this should look is your 10.934 minus 9.466 should be in parentheses in your calculator, and then hit divide by 2. Okay, so when I do that in my calculator, I get 0.734. Right, and then you're good to go. All right, now let's work the second example. So here we have the example lobster weights. Again, we've done quite a few of these lobsters. A normally distributed random sample of 23 full-grown lobsters has a mean weight of 21 ounces and a standard deviation of 3.0 ounces. We have a 95% confidence interval and use the confidence level and sample data to find the margin of error E. All right, so once again, we're going to find our confidence interval, just like last time, and then find E from there. Okay, so here we are given that we have a sample of 23 full-grown lobsters, so N is 23. So then we are also told that we have a mean weight of 21 ounces. This is a sample mean because we're working on estimating a population mean, so we know that has to be a sample mean, so X bar is 21. And then we're told that we have a standard deviation of 3.0 ounces. Now this standard deviation does not have a symbol attached to it. So I have to quickly decide for myself, is this a sigma or population standard deviation, or is this an S or a sample standard deviation? Well, since it says in the first part of the problem that this is a random sample, I'm going to assume that this is a sample. So I know that S is 3.0. So I have a sample standard deviation. And then I need a 95% confidence interval. So my confidence level is 0.95. All right, so I know the information that I'm given. Now I need to decide between S and T. Right? Again, early in this video, we saw the formula chart and looked at the requirements for S or T. Okay? So let me bring that up just to remind ourselves real quick. So for T, or for S, I need sigma to be known and a normal population, or a sigma known and a sample greater than 30. For T, I need sigma to be unknown and a normal population, or sigma unknown and a sample of greater than 30. Well, I'm not given sigma. We just said that I had a sample standard deviation. So I'm going to use the student T distribution. Okay? So then I look for the confidence interval under the student T row, and I notice that I'm going to use the calculator function T interval. Okay? Again, just like last time, I'm not going to use that by hand formula. I'm going to use the calculator. So I will use T interval. All right? So given S, use t interval. So let's load our information into t interval and get our confidence interval. Okay? So let me clear and erase this real quick. So to get to t interval, I'm going to hit stat, go all the way to tests, and then t interval is going to be the 8th option down. So I hit t interval. All right, again, that first line is input, and I need to make sure that I'm on statistics because I'm not given a list of data. So make sure that the statistics option is highlighted and blinking. All right, now notice then it gives me a list of things to fill out. I need first my sample mean, which was 21. I need my S, which we said was 3. I need my N, which we said was 23. Okay, and then I need my confidence level, which was 0.95. Okay, notice here that my sample size was not greater than 30. Just a quick note, my sample size was only 23, but I was told that this has a normal distribution already. So that saved me. If this problem didn't tell me that it was normally distributed, I maybe would have to abandon ship. Put those lobsters back in the ocean. All right, and then I hit calculate. Now you'll notice that student T did not run quite as quickly as the Z interval function. The T, anything with T interval does take the calculator quite a bit to run. So once again, hit enter once, let it think. Otherwise, you're going to get an error, okay? Just give it a minute and it'll get there, I promise. All right, so once again, as with all these problems, my answer is going to be the first entry that has those 2 numbers in parentheses, okay? So my lower confidence limit is 19.703. And then my upper confidence limit is 22.297. Okay, so let's minimize. I'm going to go ahead and keep with what the last problem said and use round to the nearest thousandths place. And both of my upper and lower limits already have those 3 decimal places, so we're just going to take them as they are. So my lower limit was again 19.703, and then upper 22.297. Okay, now my formula for E we saw on the last slide. It is also in your notes. Remember, is upper minus lower and divided by 2. Okay, so that becomes 22.297 minus 19.703 in parentheses, and then divide by 2. Okay, I'm going to put that in the calculator, and I get 1.297. And I'm good to go.